Hey guys, continuing lesson 21. Gosh, what day is this? I'm so out of it right now. I'll try to get back to it. I want to give you the best. Oh, it's day 2. Okay, lesson 21, day 2. And we are on the next page because I realize now we were not done talking about the conversation between discrete and continuous and how that impacts your choice for the domain of a function. So let's go ahead and talk about example 3. A cereal bar contains 130 calories. Look it up. The number C of calories consumed is a function of the number B of bars eaten. So what depends on what? And there's a little bit of notation. I guess, you know, the number C consumed is a function. That language right there tells me that I'm looking at the dependent variable. And then of the number. So when I see of, that tells me of the number B, that tells me independent. And one of the things that you need to be familiar with, especially if you go back and redo some of the Algebra Foundations work in Khan Academy, is that the thing that depends, the variable that depends, probably has language like comes from, you know, of, some sort of thing like that. And whatever happens after that is going to be the independent variable. That also should kind of make sense. You're going to tell me that you ate 150 calories because, well, because why? Whatever you say next is going to say the number of bars you've eaten. And because you said the number of bars you've eaten, that means that the number of bars is independent. That also describes the domain because it's the x, because it's the input. And therefore, the other thing, dependent, is the range, which is the y, which is also known as f of x, which is the output. All of those 4 statements, maybe even technically another one to make 9, the fact that y equals f of x. You got to be like fluid with those. Okay, so is the domain discrete or continuous? Arguably it should be discrete. However, I guess you could eat a portion of the bar. You could eat all of the bar. You could eat a bar and a half. You could eat a bar plus pi extra. Well, that's kind of tough because pi is irrational and, you know, actually physically pointing to a number of countable things that are, ooh. Okay, I've convinced myself it's discrete, but I'm willing to accept an argument that it's continuous. I will say it's discrete if you can eat only, that's an E, guys, only whole bars. No fractions of a bar. No like irrational amounts, square roots of 2 bars can be eaten. Okay? Which, by the way, that's why I think it should be only discrete ever. But you could say that it's continuous if smaller, even irrationally small portions can be eaten. Okay. So therefore, should the domain be the set of all integers or of all real numbers? And the answer is no to both. Kind of like the previous video where we had that previous question where it was no to both. The point is, it's all positives because you're going to tell me you're going to eat a negative cereal bar? No way. Only positives. Now it could be all positive integers. If you're saying that you're going to eat a whole cereal bar, no waste, you wasteful people. But positive real numbers could also be a thing. I don't know if you really want to eat 1,000,000 bars, but there it is. Okay, what's the domain of this function? So let's describe domain of the cereal bars to be the set of all B such that B is a positive. And then what do you want to put right there? Real number, integer? I'll put integer. Well, if you mean we can have other things, let's just put real number. There we go. That's our domain. Exercise 4. The function m equals 50 minus 9d represents the amount of money in dollars that you have after buying, I guess I should use blue, D DVDs. Is the domain discrete or continuous? Has to be discrete. You can't buy a fraction of a DVD. That's broken. So therefore, only whole numbers of DVDs can be sold. So you can't buy a fraction of a DVD. That's broken. So therefore, real number solutions, fractions, irrationals, etc., they're out. Don't count. So should the domain be the set of all integers or all real numbers? No, it should be all positives. That's a should be. Should be all positive integers. Okay. And then what's the domain of this function? Well, do what we did before. So extra practice, you need to do it, but it looks like this. That's my song. Exercise 5. Oh, you know what? This is right there at the end of the lesson. This is extra practice as well. And if you don't do it, I'm going to get you. Okay. A codomain is the set of all possible values that could come out as the output of a function. How does this differ from the range of the function? The range of the function is all numbers that do come out. The codomain is anything that could. So let's talk about that in terms of the cereal bars. You could eat 1 million cereal bars. You won't, bet, you won't, but you could. So therefore, 1 million is part of the codomain because you won't eat 1 million cereal bars. But you could, so therefore we talk about what will and what won't happen. And really, I mean, honestly, you're freshmen, sophomores, whatever, in high school. You're still young, you're still there. So therefore, when we talk, where'd you go? Oh, it went away. Range is the only thing we really need to worry about, but I just want you to be aware. Sometimes like a number that's an output is just ridiculously, ludicrously not possible. So having 1 million calories given to you because you ate 10,000 candy bars. No, that doesn't happen. It could, but it won't. All right. The lesson here is nearly done. Oh, wait, welcome back. Please make sure you do this part, because I'll get you there too. And then, great Smarter Balance question. Great conversation around should it be all real numbers, all integers, or even all multiples of 3? Because maybe you can't buy 1 or 2 or 4 or 5, but you can buy 3, 6, or 9. Okay. And then after this should be the problem set. Yep, get it done. Extra practice. Lesson 21. Out. Like and subscribe.